Hey everyone! Today, we're exploring an incredible breakthrough in nanofabrication technology that allows precise construction of nanostructures deep inside silicon. This method, developed by a team at Bilkent University, uses spatial light modulation and laser pulses to create advanced nanostructures with potential applications in electronics and photonics. Let's dive into this exciting innovation. Welcome to TrendStorm. Chapter 1: The Breakthrough. Silicon is the cornerstone of modern electronics, photovoltaics, and photonics. However, traditional nanofabrication techniques have been limited to the surface of silicon due to the challenges posed by existing lithographic methods. These methods either fail to penetrate the wafer surface without causing alterations or are limited by the micron-scale resolution of laser lithography within silicon. Inspired by Richard Feynman's famous dictum, "There's plenty of room at the bottom," this new technique developed by the Bilkent team overcomes these limitations. They have enabled controlled fabrication of nanostructures buried deep inside silicon wafers with unprecedented precision. Chapter 2: Advanced Laser Techniques for Nanolithography. The team tackled the dual challenge of complex optical effects within the wafer and the inherent diffraction limit of the laser light. They employed a special type of laser pulse created by an approach called spatial light modulation. This non-diffracting beam overcomes optical scattering effects that previously hindered precise energy deposition, inducing extremely small, localized voids inside the wafer. Professor Tokel explained, "Our approach is based on localizing the energy of the laser pulse within a semiconductor material to an extremely small volume. This leads to sub-wavelength and multi-dimensional control directly inside the material. We can now fabricate nanophotonic elements buried in silicon, such as nanogratings with high diffraction efficiency and even spectral control." Chapter 3: Enhancing Nanofabrication Through Laser Polarization. The researchers used spatially modulated laser pulses, technically corresponding to a Bessel function. The non-diffracting nature of this special laser beam, created with advanced holographic projection techniques, enables precise energy localization. This results in high temperature and pressure values enough to modify the material at a small volume. Dr. Asghari Sabet, the study's first author, added, "By leveraging the anisotropic feedback mechanism found in the laser material interaction system, we achieved polarization-controlled nanolithography in silicon. This capability allows us to guide the alignment and symmetry of the nanostructures at the nanoscale." Chapter 4: Future Implications and Applications. The research team demonstrated large-area volumetric nanostructuring with beyond diffraction limit features, enabling proof-of-concept buried nanophotonic elements. These advances have significant implications for developing nanoscale systems with unique architectures. Professor Tokel stated, "We believe the emerging design freedom in arguably the most important technological material will find exciting applications in electronics and photonics." The beyond diffraction limit features and multi-dimensional control imply future advances, such as metasurfaces, metamaterials, photonic crystals, numerous information processing applications, and even 3D integrated electronic photonic systems. Chapter 5: Concluding Remarks on Nanoscale Fabrication Innovations. Professor Tokel concluded, "Our findings introduce a new fabrication paradigm for silicon. The ability to fabricate at the nanoscale directly inside silicon opens up a new regime toward further integration and advanced photonics. We can now start asking whether complete three-dimensional nanofabrication in silicon is possible. Our study is the first step in that direction." This groundbreaking method of nanofabrication inside silicon using spatial light modulation and laser pulses could revolutionize the fields of electronics and photonics. Source: Bilkent University. If you found this video informative, don't forget to like, subscribe, and hit the bell icon for more updates on the latest scientific discoveries. Let us know in the comments what you think about this new research and its potential impact. Thanks for watching, and see you in the next video.